Let's finish trig-related rates homework with 47. It says a wheel of radius 30 centimeters revolves at a rate of 10 revolutions per second. A dot is painted at a point P on the rim of the wheel, okay, in our figure here. Find dx dt as a function of theta. Okay. So first we can find what d theta over dt is. 10 revolutions per second, we want to get this in terms of radians, and so we know it's going to be 2 pi radians per revolution. So if we cancel out the revolutions, we get 2 pi radians per second, so that's going to be our d theta dt we're going to use to help solve our problem. So part A, find dx dt as a function of theta. So we first need to identify the trig function that will relate theta, x, and 30 together. So we can use cosine. Cosine of theta is equal to adjacent over hypotenuse. I can also rewrite this as 1 over 30 times x. Okay. We find the derivative of each side. Cosine of theta becomes negative sine theta, but we have to attach d theta dt. 1 over 30 times dx dt. Trying to solve for dx dt, since that's what part A is asking for us to do. I'm going to move the 30 over to the other side, to the left side. So I get negative 30 times sine of theta d theta dt. Rearrange it with dx dt on the left side. Dx dt is negative 30 sine theta d theta dt. We know d theta dt from part A is 20 pi. So dx dt is negative 600 pi sine of theta. Right, combine the 20 and negative 30 together. Okay, part B, we're going to skip the graphing portion. So part C, what is the absolute value of the rate of change greatest, and what isn't the least? So the absolute value of dx dt, negative 600 pi sine of theta. If you think about theta changing, sine of theta, if you think about sine function, it's always going to oscillate between negative 1 and 1. So the greatest will be whenever sine of theta is 1, right? Because any value between negative 1 and 1 will be smaller, will make this value smaller. So, and also we're talking about absolute value, so everything here will just turn to be a positive value. So either when sine is 1 or negative 1. And so that will occur when we have intervals of pi over 2. So pi over 2 plus n pi. So pi over 2, 3 pi over 2, or if you go backwards, negative pi over 2, negative 3 pi over 2, so on and so forth. Right? And dx dt will be the least when sine of theta is at its smallest, when sine of theta is 0. So sine of theta is going to be 0 at intervals of pi. So 0, pi, 2 pi, 3 pi, negative 2 pi, so on and so forth. Okay. Part D, find dx dt when theta is equal to 30 and when theta is equal to 60. So when theta is equal to 30, we can just plug, replace theta with pi over 6. We know sine of pi over 6 is 1/2. So dx dt will simply be negative 300 pi centimeters per second. And when theta is 60, we can plug theta pi over 3 for theta. So sine of pi over 3 is square root of 3 over 2. Negative 600 pi times root 3 over 2 is negative 300 pi root 3 centimeters per second.